Over 4 million individual parts. More than 1,500 engineers and technicians working in unison. A double-deck flying palace that can carry up to 850 passengers and weighs over 560 tons at takeoff, yet rises gracefully into the sky. This is no ordinary airplane. This is the Airbus A380, the largest commercial passenger jet the world has ever known, so vast that a football field could rest across its wingspan. Hidden in the quiet city of Toulouse, France, and mirrored by satellite plants across Europe, lies the giant final assembly line where these super jumbos are born. Inside, technology, logistics, and human expertise converge in one of the most ambitious industrial operations in history. But how is it possible that something heavier than 300 elephants can glide at 900 kilometers per hour, cruising 11 kilometers above the Earth for 15 hours straight? What invisible science and precise choreography allow a machine of this size to defy gravity and bring continents closer? To answer that, we'll walk through the colossal Airbus factory and witness the A380's journey from blueprint to sky. The story of the Airbus A380 began in the early 1990s. Air travel was booming, and major hubs like London and Tokyo were reaching capacity. Airbus engineers imagined a new kind of airplane, double-decked, ultra-quiet and highly efficient, capable of carrying more people per flight and easing congestion. Designing such a giant required a revolution in technology. More than 1,000 engineers across Europe collaborated virtually, pioneering digital 3D modeling long before it became standard. Every curve of the fuselage, every kilometer of electrical cable, every load-bearing rib inside the wings was modeled in a single shared digital environment. They faced daunting questions. Could a wing of this size, 80 meters tip to tip, be both light enough to lift and strong enough to withstand turbulence? Could a cabin 2 decks high maintain perfect pressure at 12,000 meters? How could millions of components from Germany, the UK, Spain, and France meet with sub-millimeter accuracy? Years of computational fluid dynamics, wind tunnel experiments, and full-scale mock-ups followed. Only after thousands of tests and simulations, from lightning strikes to extreme crosswinds, did the world's biggest passenger jet earn approval to leave the digital world and enter steel, carbon fiber, and human hands. At the core of every A380 are 4 turbofan engines, each a masterpiece of modern aerospace engineering. 2 engine types power the Super Jumbo, Rolls-Royce Trent 900 or Engine Alliance GP7200, each capable of delivering up to 84,000 pounds of thrust. The process begins in specialized engine plants in the United Kingdom, Germany, and the United States. Nickel-based superalloys built to endure 1/600 decin are cast into turbine blades and discs that must survive spinning over 3,000 times per minute for hours on end. X-ray and ultrasonic inspections ensure tolerances within thousandths of a millimeter. Months of assembly follow. Technicians integrate compressors, combustion chambers, and fans larger than the fuselage of a private jet. Every stage is meticulously balanced so the engine can run smoothly for tens of millions of revolutions without a flaw. Before leaving the engine plant, each unit endures full thrust ground runs, vibration analysis, and even bird strike simulations. Only after passing these rigorous tests do the engines travel, often by ship or the special Airbus Beluga transport plane, to Toulouse, where they will meet the giant wings that await them. These engines don't just push the A380 forward at Mach 0.85, they also power its electrical, hydraulic and pressurization systems, giving life to an aircraft the size of a 10-story building. The A380's wings are the largest ever built for a commercial aircraft, spanning 80 meters, wider than an entire American football field. Each wing begins its life in Broughton, Wales, where enormous carbon fiber panels and high-strength aluminum-lithium alloys are assembled inside jigs the size of city. Block-style autoclaves, industrial, pressure ovens heat these panels to 180 degrees C under immense pressure, fusing them into a structure that is both lighter than steel and stronger than titanium. Inside the wing runs an intricate network of fuel tanks holding 320,000 liters, electrical wiring, and hydraulics that power the flaps and ailerons. Robotic drills and human artisans install hundreds of thousands of fasteners, each checked to a precision of 0.2 millimeters. Because the A380's wings must flex upward by several meters in flight without cracking, engineers reinforce them with carbon fiber spars, thicker than a tree trunk but far lighter. Before shipping, every wing is pressure tested, scanned with lasers, and inspected with ultrasonic probes. Finally, these colossal wings embark on a unique journey. They travel by barge along the River Dee, across the English Channel, and up the Garonne River to Toulouse, an extraordinary logistical ballet that unfolds with clockwork precision. The heart of the A380 is its double-deck fuselage, built in massive sections across Europe. The forward section and cockpit come from Saint-Nazaire, France. The central fuselage and upper deck are built in Hamburg, Germany. The tail cone is assembled in Spain. Each segment is the size of a small building, containing pre-installed cabin floors, wiring looms and air conditioning ducts. High-tech riveting and friction stir welding create joints stronger than the metal itself. Inside, frames and stringers form a rigid lattice, enabling the fuselage to withstand pressure differences of more than 8 pounds per square inch, while maintaining a smooth, quiet ride. Every doorway and panoramic window is sealed to remain airtight at 50 degrees. Before shipment, each section undergoes hydrostatic pressure tests and detailed 3D scans. Only when flawless are these immense barrels, each weighing up to 100 tons, transported by road and river on custom-built barges and trucks that sometimes close highways overnight. Watching these building-sized components glide through European villages is like seeing a moving city, an unforgettable stage of the A380's creation. All the pieces converge at the Jean-Luc Lagardère plant in Toulouse, a hall so vast that clouds can form near its ceiling. Here, the A380 takes shape in a precisely choreographed sequence. Fuselage join, forward, center, and aft sections are aligned by laser to within half a millimeter and locked together with giant titanium bolts. Wing attachment. Each 80-meter wing is hoisted by overhead crane and fitted with massive pins and structural adhesives, then inspected with ultrasonic sensors for hidden flaws. Tail installation. Vertical and horizontal stabilizers from Spain are mounted, giving the aircraft balance. Next, teams fit the landing gear. 22 wheels designed to absorb the impact of 560 tons touching down at 250 km/h hydraulic actuators and digital sensors ensure the gear can deploy and retract flawlessly thousands of times. The 4 Rolls-Royce or Engine Alliance engines are then carefully mounted and wired to miles of fuel lines and power circuits. Meanwhile, electricians thread 500 kilometers of cables through the decks, linking flight computers, cockpit controls, lighting, and entertainment systems. Cabin specialists transform the bare metal interior into a flying hotel, installing 2 complete passenger decks with galleys, lounges, luxury suites, and state-of-the-art air filtration and lighting systems. Finally, skilled painters apply multiple ultra-thin coats of anti-corrosion primer and airline colors, adding beauty without unnecessary weight. Before a single passenger boards, the A380 faces relentless testing. Ground tests, hydraulic systems are pressurized, wings are flexed upward several meters. The cabin is sealed and pressurized to simulate 12,000 meters altitude. Electrical checks, every circuit is powered, and lightning simulation rigs verify safety in storms. Landing gear cycles, the 22 wheels are deployed and retracted hundreds of times. Then come engine runs on the tarmac. Technicians push the 4 giants to full thrust, monitoring vibrations, fuel flow, and exhaust temperature to a tolerance of fractions of a degree. Finally, the A380 takes its maiden flight with a dedicated crew of test pilots and engineers. They perform steep climbs, tight turns, and emergency simulations, while ground teams receive live telemetry on structural loads and engine response. Only after weeks of flawless performance does the aircraft receive its airworthiness certificate, ready to carry passengers on intercontinental journeys of 15,000 kilometers or more. For Airbus, perfection is not a goal, it's the baseline for safety in the sky. From the first digital sketch to the thunderous first flight, the Airbus A380 is more than a plane. It is a monument to human ingenuity, the combined effort of thousands of people across dozens of nations. Inside this factory, imagination and precision create something almost unimaginable. A double-deck flying city that makes the world smaller and brings people together. The next time you see an A380 tracing a white arc across the heavens, remember the hidden story inside each majestic wing and pressurized cabin, millions of parts, years of planning, and countless hours of labor, all for the simple miracle of safe global flight. Which part of this colossal process amazes you most? The transcontinental logistics, the silent precision of final assembly, or the raw power of those 4 Rolls-Royce engines? Thanks for watching this video. If you found it interesting, please leave a like, share, or a comment, and don't forget to hit the notification bell so you don't miss our next upload.